So next we have Sebastian Ramirez Montano, who's going to be talking about, wait for it, mixing async and blocking code. So Sebastian Ramirez Montano is creator of the Fast API, which is used by Netflix and Uber. It was rated as the third most beloved web framework on Stack Overflow, so high praise, and in the 2021 developer survey. So please welcome to the stage, Sebastian Ramirez Montano.
Nice. Awesome. I think we all can see that. Thank you very much for having me. We're going to talk a little bit about mixing async code with blocking code. I have a lot of slides, so I'm going to have to speak in cursive. It's going to be a bit fast. Let's go. So I'm Sebastian Ramirez, or Triangulo. I live in Berlin, Germany. You can find me online. I'm actually from Colombia in South America, so that's why the accent. I created Fast API, Typer, and a bunch of other projects. But we are not going to I'm not going to talk about this today, just only a little bit about async. But mainly, we are going to talk about async and await and how to mix that with the blocking code and how to work with async and await. So first, async and await is for handling concurrency and like getting good throughput through concurrency. Let's start with what is the deal with this. So if you write a Python backend, a Python API or something like that, the Python code is actually very, very fast if you compare it to the network. So the thing that is normally the bottleneck is the network that is going to be very slow. When the client sends a request, it has to go through the network very slowly, then it reaches your Python backend, then it executes, and this part is actually very fast. Then it has to go back through the network very slowly until it reaches the client. So how can we improve this thing? Then we could say that we could have multiple clients talking to the same backend, which is what you will normally do. And this idea sounds great, but the problem is that normally this actually looks like this. It's like when you are in a grocery store and you have to wait in the line to go to the cashier. This guy, like I don't know, this guy has to wait for this guy to finish buying the toilet paper to be able to buy the groceries. And this guy has to go to the cashier, slowly pass each one of the items, then find the cash, and while all this is happening, everyone else is just waiting, not doing anything. So that is the problem, that there's a lot of parts of this system that are just waiting without doing any work. So it actually looks more like this. The client sends the request slowly through the network, then Python can process it very quickly, and then send the response very slowly back to the client. And then the other clients have to be waiting, just waiting, not doing much. Of course, this is a simplification, but it's like, this is the rough idea. And then your API app is just like waiting for things to happen. So what we would want to have is something like a waiter, so that you can be on a table, and then someone comes and asks for your order or gives you the menu. And while you are checking the menu, instead of the waiting just being there, waiting for you to check, the waiter can go to another table and ask the other table what they want, or like give them the menu. So instead of having a bunch of people just waiting at the same time, you have as few people waiting concurrently during the same period of time. So it will be more or less something like this. Here you have your backend, and then the waiter is what async and await will give you to your code. So it's provided by Python. Then the waiter will go to the first client, give them the menu, and then while the client is checking the menu and deciding what they want to buy, the waiter will go to the next client, and so on and so on. For example, this client might be my sister. She's going to take a long while just checking the menu and deciding what she wants. So while she's just waiting and just like reading the menu and thinking, the waiter can just go to the next client and then go to the next one and the next one, and the waiter can give all of them the menu, then can take the orders, everything, while my sister still doesn't know if she wants chicken or not. But then, meanwhile, the waiter, which is this component inside of Python, that is what is giving you async and await, is going to be giving all that information to your app. So your app will be kind of the kitchen. Your own code will be kind of the kitchen. And then you won't have cooks and chefs just waiting without doing anything. They will be always cooking stuff and always preparing the dishes for the clients. So you will take all the advantage of all the CPU that you have, and you won't be just like waiting without anything happening. This is the whole trick. It's just like reducing the amount of parts that are just like waiting, doing nothing. Now, there are just so many terms, and this is like sometimes confusing. It's like we have parallel, and we have concurrent, and throughput, and all that stuff. So parallel means that things are happening at the same time, so exactly at the same time. Concurrent means that things are happening during the same period of time, and this is actually a little different. At the same time, it's not like, I don't know, I'm moving both of my hands at the same time, but concurrent is during the period of time. During this period of time, multiple things can be happening, not exactly at the same time. So one will happen at some moment, then it will pause for a little bit, then another thing will happen during that same period of time. Even if it's not finished yet, it will pause for a little bit, and then the next will continue, and so on and so forth. So in all the parts that different components have to be waiting, instead of just everything waiting, you can switch to use the CPU and to use the compute power that you have for other work. So this is normally happen just in turns. That's what it means. Now, if you have a lot of waiting, for example, you have multiple users, or you have my sister in the restaurant, then you will want to have concurrency. Concurrency means that things happen during the same period of time, interleaved with each other. It could be interleaved with each other. If you have a lot of the same CPU work, so you just have to crunch a lot of numbers, you just need a lot of work, then you probably need, or like, for example, you need to use GPUs, or you need to do things like image processing or stuff like that. That is just like heavy computing. Then you probably need parallelism. So you are going to need to use more cores, to use more processes, more CPUs. This is not about who is waiting and who isn't. This is just about having more compute power directly. So async and await is particularly for concurrency. Now, in which cases would you want to have just parallelism, just without async and await? If you have well, first, the throughput, which is one of these terms that we say like, oh, it has much more performance in terms of throughput, and it's like, what does that mean? It's just the amount of items passing through. So it's the requests per second. If you have 1 million clients per second, it's not necessarily that they are being handled exactly during the same instant. It's just that they are being handled during the same period of time. So that's when concurrency helps. If what you are dealing with and the performance that you want to improve is just the latency, which is how long each individual item takes. So if you are not handling millions of users, but just one single user, and you want to serve this single user very, very fast, then what you need is not really concurrency. Concurrency is not going to help much, because you are not waiting for something. You are just like needing to process something very, very fast. In this case, you will get like better improvements and better performance from optimizing code, writing extensions, using NumPy, using GPUs, using something that compiles to some compile language, and then using it from Python or things like that, instead of just like using async and await and concurrency. But when you have a lot of users, when you have an event-driven API, when you have another type of API, then in that case, it can help a lot to have these concurrency utilities. Now, this has been just like boring terms. So let's actually use some async and check some code. So first, what are the rules of async and await in Python? So you can only use await. Await is this keyword in Python. This is how you tell Python, hey, this thing is going to take a while. So you might want to go and work in something else. You might want to work. So this is when we are telling it, hey, my sister is deciding if she wants chicken or not. So this is going to take forever. Just go and work on something else. Now, for this to be able to be used, this function has also to be async. So we can only use await inside of async functions. So this function async command, this has to be async for us to be able to put await inside. And to call an async function, the function needs to have await in front of it. So this function do work has to be async as well. This is how we will use, for example, if we have multiple functions, then we will say do work is going to be an async function. This also waits for something inside. This could be asking my sister if she wants chicken or not. So this is just going to take a while. And this is async. So we don't really have to be in front of her for her to think. So we can leave and do some other work. So we can just leave that and wait for that. Now in the main function has to be async, and then we can call this other async function to work inside of it using await. So this is the trick. Now, if you can only await inside of async, but to call async you have to use await, then how do you run this code? How do you start the main program? And the trick is that you don't call it directly yourself. You use another tool in Python, some tool, that will be in charge of setting everything up and then starting all the work. In this case, we will use any IO, and then with any IO, we will tell it, hey, go and run my function main. So we are not directly awaiting for main. We are telling any IO, go and do everything, and just await for the function yourself. So we never have to do, in our code, we never have to figure out how are we going to call a main from somewhere else if it has to be an async function, like, how do we start this? So we don't really have to wait for a function if we just don't call it. We just give it to any IO for any IO to call it for us. That's the whole trick. Now, how would you actually use it? How would you work with async and await normally? For example, let's say that you have a FastAPI API. So FastAPI underneath is an async framework, so you can use async. And when you use async with FastAPI, you have to make sure that the tools that you use internally are also compatible with async. So in this case, we are using HTTPX. Then we create this async with block, and then we can use await inside of this. Now, if you have 1,000 users sending requests, FastAPI will make sure that each of these functions is being called concurrently. So you don't have to do anything else for this to handle all the concurrency and be able to handle, I don't know, like 10,000 requests per second or something like that. And in that case, that will be just, like the simplest way to do it. And then you will get like the automatic documentation interface with OpenAPI and all that stuff. And you can, execute with it. It will work just as if you were using blocking functions. Now, with a FastAPI, with HTTPX, and a few other libraries, they are both compatible with async and non-async code. So in the case of FastAPI, you can also use non-async functions and call HTTPX directly, and then everything will just work. This is what you will do most of the times. This is what you, by default, you will probably do. And then FastAPI will make sure to do the things to run all this stuff in a way that is compatible with async and await. It's just that you can do it. So in some cases, you actually can mix async and await in the code without doing much more effort. In the case of FastAPI, you will have some endpoints, some path operations that are async and some that are blocking, and then it will just do the thing that it has to do underneath. Now, if you are not using FastAPI, but you want to use async and await in your own code, then how do you actually do that? So the first thing is, like, we say that we have to call await inside of async, and we have to have an async function. Now let's say that we have to call 3 times this function. If we use await one after the other, we are just going to a table, then awaiting, and then going to the next table, and then awaiting, but you are not actually going to each one of the tables during the same period of time. We are just waiting for each one of the tables. So this is actually not concurrent. We are just using a lot of keywords here with await and stuff, but this is not going to do the work with a high throughput, with a high concurrency and all that stuff. So you're just using async, you're using an await, but you're calling everything sequentially. This is not great. You're not really doing anything. Now, how do we manage to actually make this concurrent? So we can import asyncer, which is this little library that I created on top of any IO, and I'm going to use it for the examples. Then with asyncer, you use one of these blocks, async with. And then with this, you create a task group, and then in this task group, you can pass the functions that you want it to call. So you say, hey, task group, I want you to soonify, which means I want you to call this thing soon. And then you can pass the arguments that you need this function to receive. So we're going to say, hey, I want you to call do work, and I want you to call it with the arguments name, Yuri, Nathaniel, and Alex. And then what this is going to do is that by the end of this block, this async, by the end of this async block, then this task group is going to make sure that each one of these functions were called before this async block finishes. It's going to call them, it's going to call them at some point concurrently. It's not going to wait for each one to finish. It's going to call them during the same period of time, but you don't have to worry much about that. You just know that after this block, then all this is going to have been called. And then now you're having stuff working concurrently. Now, asyncer is using like all the type tricks and all the stuff so that you can get automatic inline errors in your editor. So for example, if you try to call do work, but you don't pass the required argument name, then your editor is going to complain and it's going to tell you, hey, you need to pass an argument for name because otherwise like this is required here. You will also get auto-completion for these arguments. This is also because asyncer does all these tricks using type annotations, the same stuff of Pydantic and FastAPI and all the stuff. So now you can have like some concurrency and some work that is just like passing and waiting for each other, and this is just like working underneath concurrently during the same period of time, waiting whenever it has to wait. Now, if you need to return some values from these functions, so now let's say that do work actually returns something. And if we call it in this asyncify task group, then we're going to need a way to retrieve those values. So when we call task group.sunify and then we pass a function with some arguments, this is going to return something here. But as I told you, this function is going to be called after this async block finishes. So right now, this sum value one, this is still nothing. This still doesn't have the return of this, because this function is going to be called by the end of everything, not right in this line. So what asyncer does is that it will give you a bunch of sum values, and then these sum values have an attribute dot value that will have the actual value returned by the function after the async block finishes. So now we can get all this data from each one of these sum values, accessing the value attribute, and this value attribute is going to be available after this block, this async block. And then, because it's also using all these type annotations and all the type tricks, then we get autocompletion and inline errors for each one of these values. So all the type information is transferred through, even if we are using async and await. And of course, we also have the inline errors and all that stuff. And because we just return that data, that is just extracting those values, whenever we use that data somewhere else, we still keep all the autocompletion and all the inline errors and all the stuff, because it's just doing all the tricks to get like all the autocompletion and all that. So now we're just doing some concurrent code by putting a bit of async salt, and that's it. Now, what happens if you want to call blocking sync code inside of async code? How do you do that? So let's say that we have a function that is not async, and that is doing something that is going to take a while, that is going to block everything, like time.sleep. This is just going to hold everything for 1 second, not letting anything else run. If we call this function inside of an async function like this, then we are going to block everything for 1 second here. No other user is going to receive a response. Nothing else is going to happen. Everything is just going to be waiting there, standing. So this is not great. Now we're calling blocking inside blocking code or sync code inside of async, and yeah, no, we are going to make this guy very sad. So you should not call blocking sync code inside of async code directly, and the trick is that this is done directly. You have to convert it to something that can be awaited in some way. And the way to do that is to run it on another thread. This might sound like, oh, this is like black magic or something, but actually, well, I'm going to show you how to do this in a little bit. So what is blocking sync code? What are actually the functions that you should not call? Are the things that don't use async, that require waiting for something. For example, time.sleep, that is just like holding everything in place for 1 second. Or stuff that interacts with something outside of your code and your variables. So something that communicates through the network, that communicates with external APIs, with external databases, that has to read files on disk, things like that. Or also something that uses a lot of CPU for a long time. So it might be just consuming CPU, just maybe doing, I don't know, some NumPy, PyTorch, something, but it's still holding that process for 5 seconds. Then that's also going to block whatever is calling that from the async side. So those are the things that you have to be aware of, like, okay, this is blocking. I cannot call this directly from an async function. Then in those cases, you can, from asyncer, you can import asyncify. And the way that you use it is that inside of the async function, you tell, hey, I want to asyncify this blocking function. And then this is going to return something that receives the parameters that you want to give it. So in this case, we want to call do sync work with the name world. And then this is going to make sure that this thing is awaitable. And now you can put await in front of that. You could not put await in front of this directly, but you can put await after you use asyncify. And then you get the message back, and that's it. What this does underneath is that it runs this function inside of a thread working inside of a thread pool that is automatically handled by any IO. But you actually don't need to know any of that. You just use asyncify, and now you can await for something that was normally blocking. And again, because this uses all the type trees and all that, you get automatic inline errors, and you get auto-completion. you also get like inline errors whenever you are passing the arguments and the parameters for the function that you want to asyncify, and you have like all that stuff. And now you can just like combine async and blocking code in the same code base. Now what happens if you want to call async code in blocking sync code, in async code? So you start with some function main, with this is async. Now in this async function, you want to call a blocking function like do work, the same that we had before. So you can use asyncify to make this something that you can await, and then now you can await for that. But now inside of this blocking function, we also want to call another function that is actually async. This do async work. This is an async function, so we have to await for that, but we cannot await inside of a blocking function. So now we can import from asyncer, we can import syncify, and then with syncify we can pass it the function that is async, and we can pass the arguments. This is just the reverse. Just the reverse of asyncify. What this is going to do is that, well, if you want the technical details, you can cover your ears. But in this case, we are going to start in the main function. This is going to run in the main thread in the event loop. This is going to pass the synchronous function to a thread worker that is going to be running, like on the side, so it's not blocking the main thread. Then that is going to call this syncify, and this is actually sending work back to the main thread with the main event loop, which is going to run this function in the same thread that is running the main function. So this is going to keep like things, like all the async stuff is going to run on one thread, and all the blocking code is going to run on one of multiple worker threads. These worker threads are managed automatically by any IO. And now we can just, the thing is like, it sounds like, oh, this is so complex. But in the end, what you just have to do is you say syncify and you syncify. And whenever you need to await for something, you just asyncify it. And whenever you want to unawait for something, you want to make something non-awaitable and just to be able to call it directly, you just use syncify. And of course, with syncify, you also get like auto-completion and inline errors and like all that stuff. Now you can do async in sync in async, and like this can get like sound weird and complex, but in the end, that is just like these two functions that can let you jump back and forth between the main thread and the worker threads, and you can just combine async and await in a way that is safe and that is not blocking your main thread and your event loop. Now, what happens if you need that your code should be able to run inside of something that is mainly async, but also inside of something that is non-async? So you're going to use any IO.run that will call your async function, which is what I have been showing you. But you also need this function sync main to be able to be called directly. So you need to be able to not use async and await directly in your application. So we need these two things to work. If we try this, by default, when this is trying to asyncify something, this is just going to break because, hey, this is not really running in something async. So this one is going to run perfectly, but this last one, sync main, being called directly, is going to say, hey, there's no event loop running. We don't have like something async to run all this stuff, so you need to do something about it. And it's just going to break. In that case, if you need this to not complain and to actually do everything to work, when you're calling syncify, you can tell it that you don't want it to raise a sync error. You want it, instead of telling you, hey, you are running this in a sync context, you are not using any async, and suddenly you are asking me to run something async, you can tell it, hey, don't complain about that, and just make everything work. And what this is going to do is that it's going to start an async event loop, it's going to run your function, it's going to return the result, and then it's going to continue and just finish that event loop. Of course, that's going to be super slow, and that's going to degrade performance if you are running something directly on something blocking, something sync instead of async. But still, you can reuse that code. If you have seen, for example, now Flask supports declaring functions that are async. This is what Flask is doing underneath. Not with this library, but like the same trick. It's just so that you can use async libraries even if Flask is not mainly an async framework. But that way you can reuse the same type of code. So this is the way that you can also do it in your own code. So you can just make sure that everything is still working, even if the code was or was not async. So now you can have mainly async code or mainly sync code, and just using async or syncify, make everything run in both contexts. It will have very good performance when it's running on async. It's not going to have great performance when it's running on synchronous code. But this is what you will do when you are in a transition to changing some pieces of code to be fully async, but you are still not there yet. So this way you can keep everything running, even if it's not the best performance that you can get. Now, which libraries would you want to use? So here's the thing. Async I/O comes with Python. It's integrated into Python. There's an alternative to async I/O called Trio. And these two support using async and await. But Trio has a couple of additional ideas that were not originally in async I/O. That is called, they call it structured concurrency. But it's that same async with the block that I was showing you with the task groups. This is an idea from Trio. Now, these two libraries are both compatible with async and await, but they are not compatible with each other. So you will have to choose or one or the other. And you, for example, you will want to use async I/O if you want to be able to use UV loop, which is the thing that has like super high performance that will make your fast API apps or like, I don't know, your async code be super fast. But that one is compatible with async I/O, not with Trio. So instead of that, you can use any I/O, and this is what I'm suggesting, because any I/O is built on top of both. And then you can use any I/O ideas and any I/O tools, and then switch back and forth between Trio or async I/O as you need to do. Any I/O is the thing that is used underneath in FastAPI and Starlet and like a bunch of others. So you should probably use any I/O, which is compatible with both async I/O and Trio, and has like this structured concurrency ideas, which makes your code a lot simpler to understand and to think about and to handle. Now you might want to try asyncer, which is this library that is built on top of any I/O that gives you all the types of stuff, all the auto-completion, inline errors, the return values, like all these additional little things on top of any I/O. Underneath, there's Trio, which has like these ideas, and async I/O, that is the one that comes with Python, and like comes with Python, and like the next versions, or like actually I think the current latest one has already some version of task groups. It doesn't still have everything, but it has like a bunch of these ideas are now baked into async I/O. And that's what I have for you, and we have like 2 minutes for questions. Thank you very much.
Okay, we have, again, a couple minutes for questions. Are there any questions that come? Yes.
Hello, I'm really sorry. I did not know you're going to talk today, but I ran here as soon as I could because I'm a user of Fast API. I know I missed most of the talk. I just wanted to give an advice to medium developers, like let's say between junior and senior. What's the best techniques, but what's to learn to become a senior software engineer? Thank you so much.
What I would suggest, and what I always suggest, is to focus on a problem that is important to you and focus on solving that particular problem. There's a lot of, like people saying like, oh, you should innovate and disrupt the market and all that stuff, and I think that's all like, that's not very important. Those are side effects of actually solving a problem and focusing on solving a problem that is important to you. When you have that focus, it can help you guide on what to study, what to learn, what to implement, what to solve, and what to do. Just like focus on solving a problem. That's what I will recommend. Also, don't focus on being a Python expert or being an expert in programming or nothing, because none of us here considers like, oh, I'm a Python expert or I'm an expert on everything. No one, not even Guido himself, considers himself an expert in everything, because it's just so broad. There is just so many things to learn that you just have to focus on whatever is going to be practical to you and it's going to help you. So, for example, Guido doesn't know much about packaging. He doesn't know about linear algebra, NumPy, all the stuff that is like, for example, data science and things like that, because that's not what is interesting to him. And he created the language. So if he can allow himself to not know everything about everything, like we can also allow ourselves to not just like try to be experts on everything. So that will be it.
If it's very quick, we can have one.
Again, I want to ask you, if we want to have tasks periodically, is it good to configure Celery with Fast API, or if we have better options, or we use, for example, a Unix-based system for periodic tasks?
You will probably use something like Celery, and that will allow you to use Fast API combined with an event-driven architecture, as Martin was showing us. You'll probably use something like Celery or RQ or ARQ or Prefect, or like there are several alternatives. You will probably use that, especially for heavy workload payloads. If you have just like, I don't know, send a notification email, maybe you can use like the integrated background tasks in Fast API, but that's only for very simple things that you that you know are not going to consume a lot, and that you are okay if they just don't really happen. But otherwise, you will configure Celery or RQ or ARQ or something like that. I'm going to be around here, and I'm going to be at the back. If anyone else has more questions, like you can also ask me later.
Thank you very much. Another big round of applause for Sebastian
Thank you very
Ramirez
much.
Montano.